So hello students, today we will discuss the leftist tree. So basically tree is one data structure which is non-linear data structure present in the any programming language, means you can implement tree using any programming language. Okay, tree has multiple different types. Okay, so we already discussed binary tree, complete tree, full tree, okay, BST, binary search tree, okay, optimal binary search tree. Okay, there are other trees also like AVL tree, red black trees and all. Okay, out of that guys there is a one concept that is leftist tree. Okay, now what is meant by leftist tree, that we have to see today. Okay, so leftist tree is a binary tree for all the internal node x. Okay, so for all internal node x we have to satisfy one condition. Now I will tell you what is meant by internal node, what is meant by external node. Okay, so what is the condition? The s value of left node is greater than equals to s value of right node. Now guys, you don't know what is meant by s value, what is meant by s value and how we are calculating the s value of any particular node. So that we have to see first, then only we will discuss what this formula is saying. Okay, the formula is very clear guys. S value of left node is greater than equals to s value of right node. Okay, so first of all we'll see what is meant by s value. The s value means the distance from the external node to the internal node, the minimum distance. Now what do you mean by external node? Might be you are thinking external node means the leaf node. No guys, external node means which is not present in the tree. Okay, so that we have to draw. Okay, so from any node which is present in the tree, okay, and the node which is present externally, the minimum distance between that is basically your s value. Okay, let's take one example guys. So here we have one node 40, then 16, then 11, then here we have 4, here we have 9, okay, and here we have 12. Okay, so guys, first of all you need to understand leftist tree is a binary tree. Binary tree means, you know, at most two children is possible. At most two children is possible. Okay, so guys, this is my tree. Now guys, I have to draw some external node here. Okay, then only we can able to calculate the distance between the external node and the internal node. Okay, so see guys, for the sake of first example we are drawing this external node. Otherwise you have to assume this, that there is a one external node and from that external node we have to calculate the distance. Okay, so this 4 is having two external nodes, this 12 is having again two external nodes. Okay, this 9 is having one external node, this 11 is having a one external node, two external nodes. Now guys, I have to calculate the distance of all the internal nodes, means the nodes which is present in the tree, okay, from this external node. Okay, so let us assume that this 12. Okay, so this 12 and the next node is external node. So the distance from the external node is 1. Okay, of this 12, the distance from the external node is 1. Now take this 9. Take this 9. Take this 9. So see, 9 is here and the left child of this 9 is external node. This is your external node. Okay, so what is the distance from 9 to external node is again 1. So guys, here we have to write 1. Okay, so 1 is the external distance. Okay, or sorry, s value of this 9 node. Okay, node number 9. Okay, now guys, let's see this 4. 4 is having two external nodes. Okay, two external nodes. So what is the distance of this 4 to the external node? Again definitely 1. Okay, 1 is the distance of 4 to external nodes. Okay, now guys, next consider this 16. Okay, now 16 is having two children, 4 and 9. This 4 and 9 is not a external children. Okay, 4 and 9 is not a external children. External children is present here. Okay, now in this case guys, what we have to do, we have to see what is the minimum value of these two children's, what is the minimum value of s value of these two children. So the both the children is having the s value is 1. Okay, so minimum value is 1 only. Okay, let us assume that 4 is having s value 1 and 9 is having s value 2. In that case the minimum value is 1. Okay, but now in this case guys, the 4 and 9 both is having same s value. That's why guys, here we can write the s value of this 16 node is minimum value plus 1, that is 2. Okay, so here you will get 2. Now guys, come to 11. 11 node is having two external nodes. Okay, so what is the distance of this 11 node from the external node? Is definitely 1. Okay, so 1 is the s value of this 11th node. Okay, now guys, comes to this root. So root is having two children and both the children is not a external nodes. Okay, now what we have to do, we have to find out the minimum s value of both the children. Okay, so here the s value is 2 and here the s value is 1. Okay, so 1 is the minimum value. So what is the s value of this 40? Minimum value plus 1, that is 2. So s value of this 40 is 2. Okay, so guys, this is how we have to calculate the s values. This is how we have to calculate the s value. Now guys, we have to check whether this tree is a leftist tree. Okay, and for that guys, we have to remember this formula. Okay, this is the formula. S value of left node is greater than equals to S value of right node. Okay, so let's see. Come to this node 12, node number 12. Okay, so 12 is not having any not having childrens. Okay, if you are thinking these are the children, these are the external nodes. Okay, so external node S value is always 0. So this is 0, 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 this is 0. External node S value is always 0. Okay, now guys, we have to see whether S value of left node is greater than equals to S value of right node. Yes, it is greater than equals to right node, so this node is valid. Now come to 9. S value of left node, that is 0. Okay, and S value of left node is 12. S value of right node is 1. Then so guys, 0 and 1. So 0 is the S value of left node and 1 is the S value of right node. So what, by the formula, S value of left node is greater than equals to S value of right node. Okay, see here formula. So the left node S value is 0, which is not greater than equals to S value of right node. Okay, it means guys, this is not satisfying the condition of leftist tree. This is not satisfying the condition of leftist tree. Okay, that's why this entire tree is not the leftist tree. Okay, this entire tree is not the leftist tree. Okay, now guys, what we can do here so that this tree becomes a leftist tree? Okay, what we can do here, what changes we can do here so that this tree becomes a leftist tree? Okay, so for that guys, what I will do, I will change the location of this 12th node. Okay, so 12th node is currently a right node, so I will make it left node. Okay, so here I have 9 and this is my 12. Okay, now here I will have one external node. This is external node and 12 is having external node. External node S value is 0, 0, 0. And what is the S value of this 12 is 1. Okay, because 1 is the distance from external node. Okay, now guys, let's see. Now it is a leftist tree or not, that we have to check. So guys, 12. Left children S value 0, right children S value is 0. Okay, so left children S value is greater than equals to right children S value. Okay, so this is valid node, this is valid node, this is valid node. Now come to 9. S value of left node, S value of right node, 1 0. 1 is greater than equals to 0. Okay, this is valid node. Then come to 4. 4, S value of left node, S value of right node, 0 0. 0 is greater than equals to 0. So this is valid node. Then 16, come to 16. S value of left node, X value of right node, 1 1. Okay, so 1 and 1 means 1 is greater than equals to 1. Okay, so this is a valid node. Come to 12. S value of left node, S value of right node, that is 0 0. So 0 is greater than equals to 0. So this is valid node. Now come to 40. So 40, S value of left node, S value of right node, that is 2 1. 2 is greater than equals to 1. Yes, that's why this is valid. So see, all the nodes is satisfying the property of what? Leftist tree. That's why this tree becomes leftist tree. So this tree is called as leftist tree. Okay, so guys, first of all, whenever you will get a one tree, first of all, you have to calculate the S values of each node, and after that you have to check this property. S value of left node is greater than equals to S value of right node is there or not. If it is there, then that tree becomes leftist tree. Okay, so guys, one more example I am taking here. I am drawing here two trees. You have to tell me whether which tree is a leftist tree. Okay, so here one, this is your model question paper example. 120, then 30, then 12, then here 8. Okay, this is one example, the one tree. Second tree is 4, 6, 3, 9 and 11. Okay, so what I am doing first, I am drawing the external node first. Okay, so this is my external node, this is my external node, this is my external node, this is the external node, this is external node, this is external node. Okay, so here also I am drawing the external nodes, this is external. Okay, so these are all external nodes. Okay, now guys, we have to check whether this is the leftist tree or not. So first of all, we have to calculate the S values of this tree. Okay, so 12 is having S value 1. Why 1? Because the distance from the external node is 1. Similarly, for 30, the distance from the external node is 1. Okay, see, 30 is having one children and one external node. That's why the distance is 1. Then 20 again the distance is 1. Why? Because 20 is having one children 30 and one children is external node. So distance from the external node is 1. Okay, now come to 8. 8 is S value is 1 because distance from the external node is 1. Then come to 5. The distance from the external node is 1. That's why the S value is of 5 is 1. Now come to the root, that is 1. What is the value of S value of verse 1? So you have to find out the minimum of S values of the children. Okay, so one of the children is having S value 1 and one of the children is having S value 1. Okay, means both are having S value 1. Okay, so 1 and 1. What is the minimum value? 1 only. So 1 plus 1, that is 2. So 2 is the S value of this one. Now come to second tree, guys. In the second tree, this come to 11. 11 is having S value 1. 9 is having S value 1. 3 is having S value 1. 6 is having S value 2. Okay, because both the children of 6 is having S value 1 1. Okay, so that's why 2. Then come to node 4. The S value is 1. Now guys, come to 2. Okay, so what is the S value of this 2? The minimum of this children's S value. The minimum of the children's S value. So children S value is 1, 2. So minimum is 1. 1 plus 1, that is 2. So 2 is the minimum value. Minimum S value possible. Now guys, let's check whether it is following, both the trees is following the concept or the property of S values. a leftist tree or not. Okay, so what is the property of leftist tree? S value left node is greater than S value greater than equals to S value of right node. Okay, so comes to this node number 12. This is node number 12. So 12 is not having any children, so we need not to worry. Comes to 30 is having one children, okay, and one external node. External node S value is always a 0. Okay, now check. S value of this left node is greater than equals to S value of right node or not. So 1 0. 1 is greater than equals to 0. That's why this is valid node. This is valid node. Okay, this is valid node. Now come to 20. Okay, so this is already valid node. Okay, now come to 20. 20 is having two children, one is original children and one is external children. External children's S value is always a 0 and the original children S value is 1. Okay, so 1 is greater than equals to 0. Yes, that's why 20 is valid. Then come to 8. 8 is a leaf node basically, so both the nodes is external nodes, so this is valid node only. Then comes to 5. So 5 is having two nodes, that is one original node and one is external node. So external node S value is always a 0 or original node S value is 1. So 1 is greater than equals to 0. Yes, that's why this value 5 is valid. Then comes to 1. So 1 is having two original childrens. Okay, now both the childrens having the S value 1 1. Okay, so left S value or left node S value is 1, which is greater than equals to right node S value, that is 1. So 1 is greater than equals to 1. That's why guys this is a valid node as per leftist tree property. So this tree is a leftist tree. Okay, now come to second tree guys. In the second tree comes to 11. 11 is the leaf node. Okay, leaf node is having a two external nodes. Okay, so this is a valid. Then comes to 9. So guys, 9 is having one external node and one leaf node. So external node value is 0 and the leaf node value is 1. Okay, so guys, here the left node is basically an external node. Left node is basically an external node. So 0 is greater than equals to 1. No, condition false. So this node is not satisfying the condition of leftist tree. Okay, there is one more node guys. This node number 2. Node number 2. So node number 2 is having two children. Oh, one children S value is 1 and second children S value is 2. Okay, now guys, the S value of left children is 1, which is not greater than equals to the S value of right children, that is 2. So 1 is greater than equals to 2? No. So guys, this is also not satisfying the property of leftist tree. That's why this tree is not leftist tree. Okay, so I hope you are getting my points guys. In the next video, we will discuss about how we can merge two leftist tree. Okay, before that guys, just see here properties of the leftist tree. The length of the rightmost path from the any node x to the external node is s of x. Okay, so what is this value? This value is called as s of x value. Okay, s of x means s value of x node. The number of internal nodes in the subtree with the root x is at least 2 raised to power s of x minus 1. Okay, so if you know the s value of any node and if you want to calculate the number of internal nodes in that subtree, then you can easily calculate with the help of this formula, that is s 2 raised to power s of x minus 1. If the subtree with root x has n nodes, then the s of x is at most log to the base 2 n plus 1. Okay, so guys, if you want to calculate the value s of x value of the root, then what you can do, if the subtree with root x has n nodes, if you know the number of nodes, then you can easily calculate the maximum value of s of x, that is log to the base 2 n plus 1. Okay, so you need not to worry about these properties, guys. You need not to use anywhere. But if they ask you theoretical question, what is leftist tree, and you have to tell the definition and these properties. Okay, so this property we basically not used in our examination, but in the competitive examination for the calculation of these S values directly, these formulas are very important. Okay, so guys, in the next video we will discuss this question: define the minimum leftist tree and meld the given minimum leftist tree. Means we have to merge these two leftist tree. Okay, so this is a very big example that I will discuss in the next